name's Yobel Haida. I'm presenting on behalf of Team 11, and this is the DP3 presentation. So, what's the problem that initiated our project design? So, what we had to consider basically was there were a lot of college students and just normal other students or workers that had problems with very cluttered desks and workspaces that needed to a place to work but couldn't just because of a disorganized or a cluttered desk. We set out to help these people, and the main audience that we decided to focus on was college students, since they were close to us and we could have access to their feedback and stuff like that. So the product we came up with is called TableMate. You can see a prototype of TableMate in here. It consists of a tabletop that can hold any device or notebooks or papers, stuff like that, files, and it has a storage space at the bottom that can hold pencils and pens, smaller devices, and it has a battery compartment in here that can contain the wires and energy for the LED light that we decided to include later in the future. The whole mechanism works on a pivot that uses the support arm and the clamp in order to span the workspace of someone when they're working on, say in a bed, for example. We will get to that later, actually. So in order to solve the problem, we had to first come up with different iterations. We had to consider a lot of different concepts in order to incorporate into our design. You can see here, for example, the clamping mechanism alone. We had to consider whether to use a vice grip type technology or just like a no hinge, just clamp that holds on the bed frame, for example, in order to support the whole tabletop. The vice grip here just uses a simple screw to tighten on the different dimensions of size beds. Another thing we had to consider was the surface, whether it would have grooves or whether we would have like a rubbery surface in order to help with slippage. Another thing, so the three main concepts that we had to consider actually were the rotation or stowability of the product, the surface capabilities, whether it have like grooves, or we actually considered having it contain like a cup holder, or in case you want to like eat while you're in bed or something like that. There's also different clamping mechanisms that we considered, such as like just gravity held, where it would just lay on top of your lap, for example, or a spring loaded, where it's actually illustrated right here in a sketch, where the springs would grip the side of the bed frame in order to support the rest of the arm that holds the tabletop, basically. So out of all of those ideas that we generated at the beginning, the 6 different solutions that we came up with are illustrated in here. You can see, for example, in solution 4 that it uses the vice type grip to support the whole body, with like charging stations and the LED light, and it also uses the rubbery kind of surface in order to help with things slipping around and stuff like that. Another thing we considered actually was the range of the tabletop that it would span across. This is a really good example of where it uses 2D joints and 3D joints to rotate all around and encompass a lot of range of motion, basically. So in considering this project, we also had to think about the intellectual property and how that might limit our design ideas, whether the ideas we had at the beginning were actually already patented and we couldn't use it, stuff like that. You can see here one of our mechanisms where it was 2D and 3D movement of the arm was actually already patented, and we had to abandon that idea. Another one where we couldn't use that idea was this one down right here, where it uses a roller support at the bottom in order to hold the device from up top, and just that idea was not really applicable to ours because we hadn't, ours was more of a support for whatever thing you were using, not really like holding a specific object from up top. So that way our product had more of a range in what it actually could do. Another big thing we had to consider was the bill of materials, obviously. We carefully considered each part of our product and what it would be made out of and how available that material is and how it would cost us in the end. So the table surface, as you can see here, we decided to cut it out of wood, most likely like birch wood or something like that. But obviously we would change it depending on the availability. We estimated it would cost around $10 for just the table surface made out of wood, and the smaller parts like wood screws and hardware would be around $0.8 per part. The support arm, which was going to be made out of the same wood as the table surface, depending on what that surface was, it has to match the table surface, and that would cost around $1.50. And the clamping jaw mechanism, which would incorporate both wood and some metal screws or hinges, stuff like that, around $2, as you can see. This is the final cap prototype that we came up with. You can see different views of it. This is like the cup holder that we considered. This would be an insert right here. You can see it clearly for the lamp that we wanted to incorporate. And this is the actual final prototype that we physically made. You can see here, we didn't get to finish the clamping mechanism, so we had to hold it down with vice grips, but you can actually see it's holding the full weight of an actual laptop, so you can see it actually works. And then this surface actually swivels around, which helps with a wider range of motion and applicability for the user. So what are we going to improve in the next coming months? Well, the biggest feedback that we got was the support strength, where the arm wasn't able to fully hold the whatever object they had. Stowability is another really big issue, and the clamping mechanism we haven't figured out yet, so we can reiterate that and come up with different solutions. Yeah, well, thank you. That's our project. Hope you enjoy.